Okay, so today we're going to look at the basically the security protocols most commonly used in network trafficking. So let's go ahead and look at the desktop. Okay, security protocols, module 6 and section 5. SSL, TLS. Most people have heard of that, even if they don't really understand what it is. They have heard of it before. It is pretty ubiquitous as far as the internet is concerned. These are cryptography protocols used to provide a secure communication environment between devices. TLS, Transport Layer Security, is more secure than SSL. In fact, SSL has actually been broken. TLS replaced SSL in 1999, but SSL is usually still used as the term. Nobody says TLS, everybody just says SSL. Security certificates are called SSL certificates. They are issued by a certificate authority after the person that orders it verifies their identity and their intentions. Then the security certificate authority will issue them a digital certificate. Basically, it's just some software with some encryption that says this person is who they say they are. You can associate that encryption certificate with a website or with a web portal. Basically, what it does is when you, let's for example, a website, if you're using the HTTPS protocol, which pretty much is common now, it checks that certificate, the browser does, before it will open up the website. And that verifies that the website is who they say they are and that they are a legitimate website conducting some kind of legitimate business on the internet. SSL, TLS, they operate at layer 6 of the OSI model, terms referring to the current TLS protocol. TLS is implemented on top of TCP to encrypt the application layer protocol. So layer 6 is on top of layer 4. TLS uses encryption algorithms to scramble the transmitted data, and you have to have a key of some type to unscramble it and decode it. The destination device decrypts it and then moves it to the presentation layer for the application so that the person that's looking at the browser window can see it. Applications that use SSL TLS include email, instant messaging, voice over IP, or telephony over the internet, and hypertext secure, which is the most common HTTPS protocol nowadays. Very few people use the old HTTP protocol anymore because it's not secure. In fact, it's easily broken. It's completely plain text. So most people use HTTPS because it is encrypted. Okay, participation activities, you have a couple of those. Then symmetric cryptography. Symmetric means equal sides, or they're both the same. Symmetric encryption is used by TLS. It's an algorithm that uses the same key to encrypt and decrypt. That's a symmetric key. It does the same thing to both. It uses it to encrypt and to decrypt. It's a secret or symmetric key. That's what's used in symmetric encryption. 2 classes, a stream cipher, which encrypts one data bit at a time, 0 or 1 at a time, and then a block cipher that encrypts data 1 block at a time. Symmetric encryption is a lot faster and more efficient than asymmetric because symmetric uses shorter keys. Asymmetric has to have 2 keys. Symmetric is used in many cryptographic protocols such as HTTPS and IPsec. And then you have a participation activity or 2. Asymmetric then. TLS also can use asymmetric encryption. 2 different but mathematically related keys are used to encrypt and decrypt. So you have a public key that is freely available to everybody. Anybody that would be using the connection gets a copy of the public key. But you have to have a private key for the public key to work. So the public key and the private key have to fit together into a key pair. The public key is not a secret, but the private key is, and can only be obtained from the key pair owner. Once you have both halves, once you have the public and private key, then you can decrypt a message. A message encrypted with a public key can only be decrypted with a related private key. The key pair enables 2 entities to securely exchange a message. They both have the public and private key, and they can both encrypt and decrypt secure communications. Message sender encrypts using the message receiver's public key, and the message receiver decrypts it with the related private key. You have participation activities. SSH, Secure Shell, is a cryptographic network protocol for operating a network service over an unsecured network. So you can use SSH to connect to a secured server over open internet. And because it uses tunneling and it's encrypted, you don't have to worry about anybody breaking into your data stream and stealing information as it comes by. SSH provides secure channel by connecting a client to a server using a client-server model. It was designed as a replacement for Telnet, which is completely unsecured and sends everything in plain text. So you never, ever, ever want to use Telnet. Some old school network admins still have that enabled, but they're just basically looking to be hacked. Telnet uses completely plain text. There's no security at all. And so it's very easy then to break into a Telnet session. SSH uses TCP port 22 by default. SSH provides data confidentiality using encryption and data integrity by using message authentication codes, MAC. Since SSH supports protocol tunneling, any network service can be secured. Basically, it's not the service that's secured, it's the pathway, it's the tunnel. Protocol tunneling is an encapsulation of a protocol's packets within the packets of another protocol. So you're not actually securing the application that you're sending and receiving with. What you're securing is the data packets themselves. It's used in SSH file transfer, SFTP or secure FTP, and also secure copy protocol, SCP. SSH can be used for public key authentication to provision access without requiring a password for each login. The authentication protocol facilitates automated passwordless logins and single sign-on. If you're familiar with single sign-on, basically you sign into a web portal somewhere, and then once you have that sign-in done, then you can access all of the things that network has available to it without having to sign into each separate application individually. Basically, this is like signing into the My Viking protocol here on the Grayson Network. When you sign into your Viking page, then you can go to Microsoft 365, or you can go to the Student Planner, or any one of those things, and you can get in there without having to sign into those because you already have single sign-on. In SSH authentication, a user's public key is stored in SSH server, and the private key is used to authenticate the user. Finally, participation activity, and then IPsec is a protocol suite for securing data communications over IP. That is layer 3, by the way. IPsec ensures the authenticity, integrity, confidentiality, and anti-replay of an IP packet. Packets are one way, one time, and they are encrypted. Two main protocols, authentication header and the encapsulated security protocol. So the authentication header provides 3 features of IPsec: authenticity, integrity, and anti-replay. For an IP packet, it ensures data integrity by using message digestion, data authenticity by using a shared secret key. It protects against a replay attack by using a sequence number in the AH header. So it authenticates an entire IP packet, and once it does that, it doesn't allow it to be replayed. Encapsulating security protocol is an IPsec protocol providing all 4 features: authenticity, integrity, confidentiality, and anti-replay for a packet. It provides confidentiality by encryption using a shared key between data and sender and receiver. Uses the same AH algorithm for providing integrity and authentication as does authentication header, and it only authenticates an IP packet. That's all it authenticates. Just those kind of packets. Got a participation activity, and then IKE and MIB. You need to go through and read that and make sure that you are familiar with those 2 things. All right, guys, once again, if you have any questions, let me know in the Canvas inbox, or contact me in class, and I'll do my best to answer your questions. Have a good day.